All right, welcome back. What I have here is we're getting ready to do our next, to figure out what's going to happen when we put two different substances and heat them up to the same temperature, and then we're going to drop them both into a calorimeters here and see which one holds on to more heat. Now, I've already taken the initial temperatures of both calorimeters. So we see here this one is reading 16, and this thing varies sometimes. So let me one more time get that in there. All right, so 15.8 or wherever that is, and this one over here is 15.2. So let's simplify that and just say that, hey, both of these are roughly 15 degrees. Okay, so both calorimeters are set. One of the calorimeters, thermometers, is slightly broken, so I'm going to use the infrared temperature gun here to do our temperature. Now, one thing to keep in mind is both of these items, the Lego figure and the screw, have the same mass. They're both 4.78 grams. So if we want to write the mass down of both substances, I'll do that right now. So the screw equals 4.78 grams. And the Lego Stormtrooper also equals 4.78 grams. So this will help us because they're equal masses. So we have to tell which one is going to hold on to more heat when we're doing that. So hopefully in your prediction, you understand that they are the same mass. All right, both these things have been sitting in there in this warm water here, and the temperature of this water that I heated up in the microwave is around 70 degrees. It's saying 69, okay, almost 70 degrees. They're going to get it in the water there. Okay, so almost 70 degree water. And now what I'm going to do, and they've been sitting in there for a while, so I'm going to take the Lego figure out and drop him in his calorimeter. And then I'm going to take the screw and drop that one into that calorimeter. And we're going to wait for it and see what happens to the temperature. I'll put the lids on. So we have our setup here, and you can see both calorimeters. Remember, both had the initial temperature of 15 degrees Celsius. Both items that we put in the calorimeters are both 4.78 grams, and both were immersed in some water that was about 70 degrees, so fairly hot. And again, we want to know which one is going to hold on to more heat and cause the biggest temperature change in the water, in the calorimeter. So we're going to let those sit so we can see, so they can release all the heat that has been stored in them. While we're waiting, I'll give you a little tour of the lab here. Carve this out. And then we got the sink here. We got some distilled water and vinegar, some BTB. If those of you who have chemistry or biology know that we've been working with that. We got some bread cooking over here in the bread machine too. So, you know, why not? And got a chemistry book back there, the biology book. Got some pots there that we're in. I know in biology we're growing some, trying to grow a tomato from a tomato. And as you can see here, we have ethanol in the back there, which we use for our biology demonstrations. Got our balance and some molecule kits and things like that. So pretty handy dandy little lab we got here. And Captain Kirk's World. Oh, Tribal Council too is hanging out today and watching this video. All right, so that should be about enough time, I think, for the two items to sit in the calorimeter. So what I'm going to do now is I'm going to take the temperature of the water after they've been sitting there and see if there's been a temperature change. So I'm going to pop this one off here first. And I'm going to grab my Lego figure, pull him out, shoot the water with my temperature gun. And water saying 17.5. All right, cool. All right, do the same thing over in this one. Pop off the lid. Grab that screw down there. pull it out and take the temperature of this one now. And